2026 A-Level Combined Mathematics Paper 1 Part B Question number 16 Part A. Part B of the same question will be discussed in a future video. Link in the top right. Part A of this question has to do with lines and circles in the Cartesian coordinate plane. The question says, let the point A be given by 3, 0 and the point B be given by 0, 2 and the line L be a line that is perpendicular to the line AB. Now given this, we are told to show that the equation of the line L has the form of 3x minus 2y equals lambda, where lambda is some element of the real numbers. The question then says, this line L intersects the x-axis at the point C and intersects the y-axis at the point D. And given this, we have to show that the point of intersection of the lines AD and BC lies on the circle x squared plus y squared minus 3x minus 2y equals 0. Now to start off with this question, let's consider the line L with the points A and B. Now if the line L is perpendicular to AB, then if we multiply the gradient of L and the gradient of AB, we should get -1. Now using this, we can find the gradient of the line L by first finding the gradient of the line AB. So considering gradient of AB, the gradient of AB can be found by using the formula y2 minus y1 divided by x2 minus x1. So in this case, we have 2 minus 0 divided by 0 minus 3 from these two coordinates. Now using these two coordinates, you can see, if you simplify, we get 2 divided by minus 3 or minus 2 over 3. Now if the gradient of AB is minus 2 over 3, then we can say, if we let M be the, let's say, gradient of L, then since L is perpendicular to AB, M times -2 over 3 must be equal to -1. And from that we can see, rearranging, we get M equals 3 over 2. So M equals 3 over 2, meaning the gradient of the line L is 3 over 2. Now from this we can say, therefore, the line L given the gradient intercept format can be written as y equals mx plus c, or y equals 3 over 2x plus c, where c is some element of the real numbers. Now we don't know what c is yet, but we'll just say c is some element of the real numbers. Now rearranging, we can see, if we multiply 2 by both sides, we can see we get 2y equals 3x plus 2c. And taking a little bit more rearrangement, we can see, if we take the 2y to this side and the 2c to this side, we get 3x minus 2y equals, on the other side we get minus 2c. Now here we can see, if instead of 2c or minus 2c we had lambda, we would get the form 3x minus 2y equals lambda, where lambda is some element of the real numbers and lambda is the same thing as minus 2c. So with that we can see, we will get L in the form that they wanted, which is L given by 3x minus 2y equals lambda, where lambda is some constant, and in this case when we took the original definition here, we got lambda being equal to minus 2c, where c is the constant in the gradient intercept format of the line L. So with that, we've shown the first part of the question and shown that the line L has the form of 3x minus 2y equals lambda, where lambda is some element of the real numbers. Now then the question says, the line L intersects the x-axis at the point C and the y-axis at the point D. Now on the x-axis, the value of y is 0, and therefore we can say, considering C, at the x-axis, y equals 0, and hence if the line L intersects the x-axis, then at that point from the line L we can see we will get the equation 3x minus 2 times 0 equals lambda. So at that point we will get 3x being equal to lambda, and therefore we'll get the equation x equals lambda divided by 3. So therefore for the point C, y will be equal to 0 and x must be equal to lambda divided by 3. Now substituting, we can see we get C being the point of x equals lambda divided by 3, y equals 0. Now similarly, since D is on the y-axis, meaning x is equal to 0, we can say, considering D, x will be equal to 0, and therefore from the line L we'll get the equation 3 times 0 minus 2y equals lambda, and therefore y being equal to lambda divided by minus 2, or minus lambda over 2. And therefore, the point D will have the coordinates of x equals 0, comma y equals minus lambda divided by 2. So this is what we get for the point C and the point D. Now from this, in order to move to the next part of the question, which is to show that the intersection points of AD and BC lie on this circle, we need to find the gradients of AD and BC. So therefore, let's go down and write down gradient of AD, and also write down the gradient of BC and try to find these two values. Now considering AD, the point D has coordinates of 0, negative lambda over 2, and the point A has the coordinates of 3, 0. So here, let's take this as y2 and the other value here of negative lambda over 2 as y1. So therefore, we'll get 0 minus negative lambda over 2, 0 minus negative lambda over 2, divided by x2 minus x1, which is going to be 3 minus 0. So divide by 3 minus 0. Now we can see this will give us negative lambda or positive lambda divided by 2 divided by 3, or positive lambda divided by 2 times 3, or lambda divided by 6. So the gradient of AD is lambda over 6. Now considering BC, for BC, the coordinate of C is lambda over 3, 0, and the coordinate of B is 0, 2. So if we take this as y2 and the other value here as y1, we'll get 2 minus 0 divided by x2 minus x1, which is going to be 0 minus lambda over 3. So we'll get divided by 0 minus lambda over 3. Now we can see here we have negative lambda at the bottom. If we take this 3 up, we'll have 2 times 3. So we'll have 6 divided by negative lambda, or negative 6 over lambda. Now additionally, we can also see here these two lines happen to be perpendicular, lambda over 6 and negative 6 over lambda. However, that is not relevant to us, since all we really care about here is the two values of the root gradients and all of the points on each of these lines based on one of the points that we have on these lines. Now AD passes through the point A, and therefore going up, if we consider A, which is the coordinates of 3, 0, we can apply the formula y minus y0 equal m times x minus x0. So here we can see we'll get y minus 0 from AD, we'll get y minus 0 equal to m, or lambda over 6, times x minus x0, which is x minus 3. Now similarly, from the line BC, if we go up and consider the coordinates of B is given by 0, 2, and therefore applying the same formula, we'll get y minus y2 or 2 equal gradient, or negative 6 over lambda, times x minus x0 or x minus 0. So we get these two equations right here. Now considering these two, if I rearrange them to get lambda, the first one will give us, if I multiply by 6, 6y equals lambda times x minus 3, and therefore lambda equals 6y divided by x minus 3. Now considering the second one, we can see if we multiply both sides by lambda, we'll get lambda times y minus 2 equal negative 6 times x, so minus 6x. Now dividing both sides by y minus 2, we can see from this one we'll get lambda equals minus 6x divided by y minus 2. Now in this case, since both of these lines must pass through the intersection point, the coordinates of that intersection point will satisfy both this equation and this equation. So we can say if this is equation number 1 and this other equation is equation number 2, then the intersection point of AD and BC will satisfy both equations 1 and 2. Now according to that, if we consider these two to be both true at the same time, we can see lambda is equal to this and it's also equal to this, and therefore both of these values must be equal to each other. Now according to that, we can also say, if we substitute in these two on both sides, 6y divided by x minus 3 will be equal to the other value of minus 6x divided by y minus 2. So we can write equals minus 6x divided by y minus 2. Now rearranging, we can see this will give us, if we take the y minus 2 to the other side and x minus 3 to this side, we'll get 6 times y minus 2 equal minus 6 times x minus 3. And dividing both sides by 6, we can see we'll get y times y minus 2 equal minus times x minus 3, and therefore we'll get y squared minus 2y being equal to minus x squared times minus 3x. Now taking this to the other side, we can see we can get the equation x squared plus y squared minus 3x minus 2y equals 0. And we can see, since the two equations that we used to get to this point were satisfied by the intersection point of AD and BC, the final equation we get, which is this equation right here, will also be satisfied by the intersection point coordinates of the lines AD and BC. So finally we can say, therefore, the intersection point of AD and BC will satisfy this equation, which is the equation of a circle of x squared plus y squared minus 3x minus 2y equals 0, and we can thus say these coordinates will satisfy the circle x squared plus y squared minus 3x minus 2y equals 0. And with that, we are done with this last part of the question. Now finally, let's consider the marks awarded for this question. So at the start of the question, when you find the gradient of the line AB as negative 203, you will get 5 marks. And after that, when you apply the fact that the line L and line AB are perpendicular and write this equation right here, for getting this and then getting m equals 3 over 2, you get another 5 marks. Now after that, when you apply the gradient intercept format here, rearrange to get 3x minus 2y equals minus 2c, and then replace the minus 2c with the different constant lambda to get the form that we wanted of 3x minus 2y equals lambda, you will get total of 10 marks. Now after that, when you consider the point C, say that it's on the x-axis and therefore y is equal to 0, and from that you get x equals lambda over 3, and write then the coordinates of C as lambda over 3 comma 0. For getting that correctly, you will get 5 marks. Now similarly for the point D, when you say it's on the y-axis, so x is 0, and substituting when you get y equals negative lambda over 2 and get the coordinates of D like this, you get another 5 marks. Now after that, from these two, when you find the gradient of AD and BC based on the points and get lambda over 6 and negative 6 over lambda respectively, you get 5 marks each. After that, when you apply the coordinates of AD and say that since A is on AD, y minus y0 equals m times x minus x0, to get this equation for lambda, for getting this equation, you get 5 marks. Similarly for BC, when you substitute the coordinates of B to get this equation and rearrange to get this equation for lambda equals minus 6x divided by y minus 2, you get another 5 marks. Now when you combine these two and equate them to get this equation right here, for getting this equation, you get 5 marks, and after simplifying down, when you get the final circle of x squared plus y squared minus 3x minus 2 equals 0, and then say, since the coordinates of the intersection of AD and BC satisfy the original equation here, they will satisfy the final equation of this circle right here, and therefore the intersection point of AD and BC will be on this circle, for concluding that at the very end after finding the circle, you get a total of 10 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.